Long before humanity learned to measure the age of stars, before telescopes pierced the darkness between galaxies, the history of the cosmos was already written across the fabric of space itself. Every point of light in the night sky is a messenger from another age. Some began their journey before the rise of civilizations, others departed their stars when Earth itself was still young. Across unimaginable distances, these ancient photons drift through the silent vacuum, carrying within them the story of creation. The candle flame holds steady in the vaulted silence of the chapel. It does not flicker. Outside the tall windows of the Catholic University of Leuven, the Belgian sky deepens toward indigo, and the first stars appear, cold, patient, indifferent to the centuries. Inside, a man rises from his knees. His name is Georges Lemaitre. The year is 1927. He is a priest, and he is also something rarer. A theoretical physicist who has looked upon the mathematics of creation and found, inscribed there in austere equations, a story that requires no miracle, no seven-day drama, no divine finger pressing the first domino, only the deep, impersonal logic of natural law and the extraordinary discovery that space itself is expanding. He stands before the chapel windows and lets his gaze travel outward. The starlight entering his eyes departed its source years, decades, centuries ago. Photons crossing unimaginable distances to arrive, faint and ancient, at this small warm room in Belgium. He allows himself to trace that journey backward. In his mind's eye, Lemaitre reverses the arrow of time. He sees the world before humanity, before civilization, before the first upright creature looked up and wondered. Further, before the earth itself solidified from the molten wreckage of its birth, a barren rocky body circling a newly ignited star. He watches the sun form, a vast cloud of hydrogen and helium surrendering to gravity, growing denser and hotter until the pressure at its core becomes so immense that nuclei fuse and light explodes outward for the first time. A star is born in a blaze of nuclear glory. But the sun inherited its raw material. That gas and dust had history. Lemaitre imagines generation upon generation of earlier stars, great furnaces that lived for millions of years, forging carbon, oxygen, iron in their cores, then dying catastrophically in supernovae that seeded the cosmos with elemental complexity. The atoms in every living thing, in every grain of Belgian soil, were forged in stellar interiors and scattered across the galaxy by those ancient explosions. We are, in the most literal sense, made of stars. He pushes further back still. Before those first stars, before the chemical complexity that makes life possible, a universe of only hydrogen and helium, vast and featureless and dark, drifting in a silence that has no ears to hear it. If space is expanding now, then the reverse of now is contraction. In the rewound universe of Lemaitre's imagination, all matter draws inward. The darkness compresses. Atoms press together until there is no space between them, until even light cannot pass through, until the universe becomes opaque, a sea of radiation in which no photon travels free. The temperature climbs, the density climbs, the atoms themselves can no longer hold their shape. Electrons are stripped from nuclei. Nuclei are crushed into their constituent particles. Everything dissolves into pure energy, a state so extreme that no instrument, no human eye, no theory yet devised can fully describe it. It can be smaller still, hotter still. Here, at the edge of the conceivable, even Lemaitre pauses. The mathematics points toward a singularity, a moment of infinite density, a boundary beyond which the equations themselves break down. He is satisfied. He has traced 13 billion years of cosmological history from this quiet chapel, following the thread of one elegant idea that the expansion of space read backward demands a beginning, a primordial atom, a first instant. What happened in that first fraction of a second, he does not claim to know. Lemaitre was the first true architect of what the world would eventually call the Big Bang, a name coined by a skeptic, meant as mockery, that became the most famous phrase in all of cosmology. For nearly a century since, that theory has been tested, refined, battered, and confirmed. The cosmic microwave background radiation, the faint afterglow of that ancient fireball, has been mapped in astonishing detail. The abundance of light elements matches the predictions of primordial nucleosynthesis with extraordinary precision. The large-scale structure of the universe, the vast web of galaxy filaments and voids, traces its origins directly to quantum fluctuations in the first moments of existence. And still, the deepest questions remain. What triggered the expansion? What governed the physics of the first instant? Did time itself have a beginning? Can minds made of matter, minds that evolved to track prey across an African savanna, ever genuinely grasp the truth of their own origin? The candle in Leuven burned down long ago, but the questions it illuminated, those questions have never stopped burning. Before Lemaitre, the great minds of the cosmos had largely turned their gaze inward, cataloging our own celestial neighborhood, charting the composition and extent of the universe we believed we inhabited. The questions were profound, but they were bounded. It was not until the 13th century that the philosopher Siger of Brabant stood alone at the precipice of heresy, venturing the extraordinary claim that the universe was eternal, without beginning, without end, suspended in perpetual existence. His words detonated like a philosophical supernova across the ecclesiastical world. The theologians recoiled. The Pope condemned him in 1277. Rumor carries the dark whisper that he was murdered with a pen, a fitting symbol for a man whose ideas had cut too deeply. And so the wound was sutured. For centuries, no serious scholar dared contemplate a universe with a beginning. The cosmos was simply there, as it had always been and always would be. Then came Lemaitre. His mathematics arrived quietly, the work of a Belgian priest-physicist who sat with the equations of general relativity and dared to follow them to their most uncomfortable conclusion. The universe, Lemaitre proposed, had not always been this vast, silent cathedral of stars and void. It had once been something incomprehensibly small, incomprehensibly dense, incomprehensibly hot, a single primordial atom, a seed of everything. And then it exploded. The idea was staggering. The universe had started its life a finite time ago in one singular catastrophic event, and the expansion we now observe across the night sky is merely the long echo of that ancient violence, still reverberating through the fabric of space-time like a sound that will never fully die. Not everyone was willing to listen. Fred Hoyle was brilliant, contrarian, and utterly unconvinced. One of the most respected astronomers of his era, he found Lemaitre's expanding universe theory not merely wrong but philosophically offensive. It was Hoyle himself who, in a moment of dismissive sarcasm during a 1949 BBC radio broadcast, coined the phrase that would become the theory's immortal name, the Big Bang, meant as a taunt, a jeer, a rhetorical belittling. He could not have imagined what he had created. For Hoyle, the implications of an expanding universe were intolerable. If the universe was expanding now, then logic demanded it must have been smaller before. Follow that thread far enough backward through time, and you arrived at a beginning, a moment of creation. To Hoyle, this was not science. This was theology dressed in mathematics. He declared it pseudoscience. He argued that our collective infatuation with the Big Bang was nothing more than the ghost of Genesis haunting the equations, that centuries of the Book of Creation had so thoroughly colonized the human psyche that we were now finding creation written in the stars because we had been trained since childhood to look for it. Lemaitre, for his part, remained serene. The priest-physicist had long since learned to hold physics and faith in separate hands. His mathematics did not yearn for theological validation. The equations neither needed God nor excluded him. They simply described what the evidence required. And the evidence, it turned out, was overwhelming. Northeast of Los Angeles, perched in the cold clarity of the San Gabriel Mountains, the Mount Wilson Observatory held the largest aperture telescope on Earth. Through its enormous eye, Edwin Hubble gazed tirelessly at the dimmest, most remote corners of the visible sky, those faint smudges of light that earlier astronomers had dismissed as mere nebulae, unremarkable wisps within our own Milky Way. He was about to discover they were entire universes. But that revelation, extraordinary as it was, would be eclipsed by something stranger still. Light, Hubble knew, carries its own biography. Luminous objects like stars emit light through the nuclear fusion burning in their cores, and that light is stamped with a spectral signature, a precise record of the star's temperature and chemical composition. But light also carries a second, more subtle record, the story of the star's motion. The phenomenon is familiar to any ear that has stood at a roadside as an emergency vehicle wails past. The siren shrieks high as it approaches, then drops to a lower moan as it recedes, the sound waves compressed by approach, stretched by retreat. Sound travels through air. This is the Doppler shift. But light, too, obeys this principle. Light from a star moving away from us is stretched, its wavelengths lengthen. In the visible spectrum, longer wavelengths register to the human eye as red. Stars fleeing from us appear redder than they truly are. Hubble pointed his telescope at galaxy after galaxy and measured their light. He recorded the spectral lines. He searched for the telltale shift. And then, with a clarity that must have felt almost surreal, the pattern revealed itself. Every galaxy was redshifted. Every single one. At first, this might seem to place Earth at the center of a cosmic exodus, every neighbor fleeing from us, as if the universe itself were recoiling from our presence. But the truth was far stranger and far more magnificent than any geocentric vanity could account for. Hubble saw that distant galaxies receded faster than nearby ones. The recession velocity was proportional to distance. This was not a pattern consistent with Earth as the center of some great flight. This was the signature of space itself, expanding, every point in the universe growing farther from every other point simultaneously, the way dots drawn on a balloon surface drift apart as it is inflated. There was no center. There was no edge. There was only the expanding fabric of everything. The mathematics Lemaitre had derived in quiet isolation now had observational bones. The universe was not static. It was not eternal. It had a history. And if space was expanding now, then time, run backward like a film in reverse, converged toward a moment, a single, unimaginably dense point from which everything we have ever known or ever will know erupted into existence. Lemaitre's hypothesis of the primeval atom had found its confirmation in the motions of the galaxies. But one final piece of evidence still remained hidden, buried in the universe's oldest light, waiting to be found by accident. In 1964, at Bell Laboratories in Holmdel, New Jersey, two radio astronomers named Arno Penzias and Robert Wilson were conducting painstaking calibration work on a massive horn-shaped antenna designed to receive radio signals bounced off early communication satellites. Their work demanded extraordinary precision. Any contamination of the signal would corrupt everything. They found contamination they could not explain. A persistent low-level hiss permeated their measurements. Uniform. Directionless. It came from every point in the sky with identical intensity, regardless of where they aimed the antenna. Penzias and Wilson were meticulous. They examined every possibility. Perhaps it was interference from the electric glow of New York City, some 50 kilometers distant. They ruled that out. Perhaps it was the pigeons that had taken to roosting inside the Great Horn, their accumulated droppings coating the interior surfaces and introducing thermal noise into the signal. The researchers cleaned the antenna with an almost comic thoroughness. They removed the pigeons. They scrubbed away the droppings. The noise remained. It was not pigeons. It was not New York. It was the universe itself, speaking in the oldest voice it still possessed. What Penzias and Wilson had stumbled upon was the cosmic microwave background radiation, a remnant fossil of light left over from an era when the universe was almost unimaginably young, unimaginably small, and unimaginably hot. In those first hundreds of thousands of years after the Big Bang, the cosmos was a roiling plasma so dense and so energetic that light could not travel freely. Photons were constantly absorbed and re-emitted, trapped in a searing, luminous fog. Then, approximately 380,000 years after the Big Bang, something changed. The universe had expanded and cooled enough for electrons and protons to combine into neutral hydrogen atoms. In an instant, cosmologically speaking, the fog lifted. For the first time, light was free. It streamed outward in every direction, filling all of space with a bath of radiant energy at a temperature of roughly 3,000 degrees. That light has been traveling ever since. As the universe expanded over the subsequent 13.8 billion years, those once fierce radiation waves were stretched along with the fabric of space, their wavelengths pulled from the infrared into the microwave range, their temperature diluted by cosmic expansion to a ghostly 2.7 degrees above absolute zero. What Penzias and Wilson were hearing in their antenna was that ancient light, now cold almost beyond imagining, pressing gently against their instruments from every direction at once. Lemaitre's calculations had predicted exactly this. These radiation scars, burned into the fabric of space at the moment of first transparency, were the universe's own certificate of birth. The Big Bang had left a fingerprint, and after nearly half a century of searching, science had found it in the static of a New Jersey radio telescope. The Big Bang Theory now stands as the accepted cosmological model, our best and most rigorously tested account of a universe born approximately 13.8 billion years ago from a state of infinite density and temperature, expanding ever since into the vast, cold, star-strewn expanse we inhabit today. The journey from Lemaitre's solitary equations to Hubble's red-shifted galaxies to the whispering microwave background is one of the great intellectual odysseys in human history, a story of mathematics vindicated by observation, of heresy transformed into orthodoxy, of a universe slowly revealing its own biography to the creatures it had spent billions of years assembling from stardust. And yet, the work is not finished. The mystery has not surrendered. For all that we have learned, for all the light we have gathered, all the signals decoded, all the equations confirmed, the universe's first moments remain wrapped in silence and shadow. At the very instant of the Big Bang, the laws of physics as we understand them collapse into contradiction. General relativity and quantum mechanics, the twin pillars of modern science, are irreconcilable in the furnace of that primordial singularity. What was the Big Bang? Not merely the event, but its nature, its cause, its context, if such words even retain their meaning at the boundaries of time itself. Why does the Big Bang break our deepest understanding of the universe? What came before, if before is even a concept that has meaning when time itself had not yet begun? The cosmos stretches in all directions, ancient and vast and profoundly silent, and at its heart, a question burns as bright as the first light that ever existed. We are still learning to ask it correctly.